Hey guys, that's Chatri. Hope you're all doing great. This video is a replay of a big live session I did with my community, originally made for newest members. The goal of this session was to help you kickstart your IT journey. I'm focusing on practical tips and diving into key concepts that many people find tricky. During the whole live, I'm presenting many analogies that will help you unlock your understanding of concepts that left you stuck or confused. And of course, guys, you need to think of it as a complement to those how-to videos or step-by-step guide. I've had some amazing feedback from my community and I'm sure you will love it too. Quick note, if you're looking for specific topics, I've dropped timestamps in the description and comments to make it easy to navigate. So enjoy the session, guys, and see you in the next video. Okay guys, we are live. I hope you're all doing well. We won't waste too much time. I know that it's been a long time that I didn't do any live, but it's a great opportunity today because there is new arrivals. So let me check if you guys are all here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay guys, okay, perfect. I know it's a bit late today, but I promised you this live, so let's get started. In this session, we're going to do things very differently from what you usually see on YouTube. There is no how-to, like how to set up your virtual machine or how to install or deploy a server. Those topics are already covered in so many other videos on YouTube, so it would be pointless. So instead, we will focus on what most people miss on YouTube, which is, for me, understanding the concept through analogies. And you know I love analogies and example when I break through concept and notions, so you could gain a clear and concise understanding while combining it with practical skills. You see? So for the new arrivals, trust me, I've been there. I started with absolutely zero knowledge in IT, so I totally get where you come from. That's why I've developed, I would say, I've developed like this teaching approach that works best for me and also for others in the chat. They can confirm. Guys, I think while I'm talking to chat, let's pause the chat during this moment. Feel free to write down your question and we will cover them during the Q&A, you know, at the end. So also a quick reminder for those who aren't on our Telegram channel this week, everybody's on our Telegram channel, but for the one who didn't look at it, this week will be packed with 3 to 4 big live sessions. So make sure you tune in because it's going to be great knowledge about, for most of you, it will be a recap, but even though it's a recap, I had like some struggle, you know, to make up, like to prepare this live a little bit, not that much, but just it was just like funny that I couldn't remember some of the concept, okay, that was linked to this. So for this live session, I don't know exactly how long it will be, but here is how we will divide it. First, it will be virtualization. So you see, like just big intro on virtualization, why it's for, why we're using it, what is it, etc, etc. Then VMware, because you see all my lab are on VMware. Also VirtualBox, by the way. I started with VirtualBox, as you know. And then installed hardware. And then I'm gonna take you to Amazon and what type of things you should buy, components, hardware components you should buy, and what is best suited to your laptop. Then I'm going to do like a quick overview of my complete Active Directory environment. Of course, guys, I'm not gonna plug all of my VMs. It's gonna take too much resources, but I have 2 sites, which the first one is on my FSMO, which is the DC2, and I have like a router that's, but I'm gonna go into this, and it's going to be very interesting for the people that never saw this type of lab environment. So yeah, forget. And then the fifth one, it's going to be networking. It's the most important one. I'm telling you, these days, so many people who don't have a clear understanding and on what is networking, and it's always give them some confusion when they tackle other subjects related to IT. It really causes a lot of issue for many people because they never going deep into networking. Okay, and we will try to do this. We will try to do that in this live session. So before we dive in, let's clarify what virtualization really means. Um, it's important, that I just do this very quickly. So imagine you have a computer, like a powerful machine, a single computer like this one. Let me see, laptop. Let's take that one, and let's say like it's a very powerful machine and it has a lot of RAM, a lot of CPUs, etc. Now imagine dividing this one machine into smaller one, like this one. In my case, I have, for example, 3 VMs. Okay, I have 3 virtual machines, but they are like independent, isolated, and they they have their own, like we allocated their own RAM, own CPU, etc. So guys, that's virtualization. Basically, that's virtualization. And now, so I think like most of you, they know about that. But I'm just gonna talk about the a key misconception is that resources, many people think that resources are fixedly divided. For example, if you assign 4 GB to 5 virtual machines, so it means 20 GB on the computer with only 16 GB of RAM, it doesn't mean that your computer actually and like strictly locks in 4 GB for each VM. So it means that in my case, for example, let's maybe take 5, okay? Because I have in my laptop I have 24 GB. So sorry, the count doesn't add up. It doesn't add up. Let's just stay with 16 GB. Imagine I have 16 GB and I have 5 laptops. You see, it doesn't fit in. The fifth laptop doesn't fit in because I have only 16 GB, so I can only support 4 GB and the rest, so it will be 4 multiplied by 4, 16, okay? But then this one I cannot fit in. The thing is, it doesn't work that way. Okay, it doesn't work that way. Instead, the allocation is dynamic. Resources are only used as needed by each machine. So if you want to see the actual representation of what virtualization is and how your VMware act, it's like this. Like it go up, go down, go up, go down, go up. And it depends on how much you are using it. For example, guys, let's imagine this, like my case, the representation of my actual laptop. I have 3 VMs right now. You see DC2, router, DC1, site1, etc. Let's say right now, because I don't use them, they look like this. And by the way, I have 24 GB of RAM. Okay, I have. Let's not use it because it will bring more. It will be a bit more confusing for me. I have 24 GB right now on my laptop. So it means that a correct representation will be this one. and the other one, and maybe let's say the DC2, I'm using it right now. Like I'm using a lot of my DC2. I mean, okay, not DC2, but DC1. Let's say DC1 because I'm going to like Google Chrome. I'm doing a lot of stuff. So sorry. So this DC1 will be like a little bit bigger than this one. And now because I'm using much more my laptop, so let's say my laptop is here, my real laptop. Let's say we will put it like red because it's my real laptop. He's consuming much more than those ones, okay? But maybe I will then consume a lot of more about my DC2. I will use more my DC2. So then this one will be active and this one will slow down because I don't use it. I don't use my DC1 for the moment. So that's why, guys, you can fit more than what you locks, than what you give to each of your VM. But you don't locks 4 GB on your actual RAM, on your actual bar RAM. So let's say here it's your RAM. You don't lock 4 GB for each of your RAM, okay? You don't do that. Actually, I mean, in reality, you are dynamically giving 4 GB depending on your use. So yeah, so guys, I'm just saying this, and I have like one good example, sorry, analogy that I really love when talking about this. It's to avoid confusion. Many people think virtualization divides resources rigidly, like cutting a pie into fixed slices. That's the thing. Many people, they confuse it and they think that we are really like, if you have a pie and here it's your RAM, here it's the RAM. People think that we are like giving slices, like pie slices, and we're giving this to each VM. This one is for him, this one for him, and this one is for him. But it's not true. It's not the correct way of seeing virtualization. The way of seeing virtualization, it's more like a buffet. You need to think of it like a buffet. You have food available, which are the RAMs. So it's like you have that. Let's make let's choose, for example, this thing. And it's exactly this way, guys. It's exactly like you have a buffet. And here they are the VMs. Like the people that you see here, they are the actual VMs. They are the actual VMs, and they consume what they need for the moment. For example, this guy is very hungry, so he will use like 3 GB, okay? And he have maximum capacity of taking 4 GB. So, and for example, this little girl, she's not that much hungry, so she will only take a little bit of vegetable, so a little bit of RAM, a little bit of CPU. So it would be maybe this one. It will be this virtual machine. So, but maybe this one will be very hungry after, and then she will use a lot of a lot of food in the buffet. Okay, so I like this analogy because it make things a little bit clearer. So let me wipe this up, and we're just gonna talk now about hypervisor 1 and hypervisor 2. I know that in the beginning, uh, many people, they had like some struggle with this definition. It's actually more about remembering the differentiation between hypervisor 1 and hypervisor 2. So it's what we will say here. So guys, hypervisor 1, the way that I remember it myself is I say that type 2 hypervisor, it's, by the way, hypervisor is just like the technology. So you have like, in order to virtualize, to enable virtualization and work with virtualization, you use a type 1 hypervisor or a type 2 hypervisor. And the way that I try to remember it is type 2, despite its high, like the number is high, but it's for cheap. It's for cheaper people. How can I say? It's cheap. Yeah. Even though the number is high, it's not expensive, but it's cheap. And hypervisor, as you know, it's VMware VirtualBox, so it's free, free alternative. And the hypervisor type 1, even though it's only one, it's the expensive, it's the one that is the most expensive. It's just my way of like my workaround to always remember the difference between type 1 and type 2. And type 1, of course, you know, guys, it's, for example, Microsoft Hyper-V, which I really love it, or VMware SKey. And what is now the differentiation between those two in terms of the concept? So type 1 hypervisor runs directly on the hardware without an an intermediary, uh, without an operating system. It runs directly on the hardware. And type 2, it's the opposite. It runs on top of the OS, like Windows, like myself. Here, you see me, I'm using my OS, and on top of it, I'm using VMware, which hosts another Windows. But in the type 1, you actually you actually directly run it on top of the hardware, so there is no Windows. So guys, I think you understand. It means that the type 1 is very efficient. um the the way that I like to also put it is, you know, guys, about okay, no, let's not take this analogy. Maybe this one is better. Okay, you need to imagine type 1 hypervisor or like an airplane's autopilot system directly flying the plane. So it doesn't need anybody. It use directly all the hardware components and the data to function, and he will act upon the data. He will see the data, how they act, what is the math, and he directly gonna act regarding the data. The type 2 hypervisor, on the other hand, are like a co-pilots who constantly checks with the pilots before making decisions. So you can imagine now why the autopilot is faster and more reliable. Because if something happened, the copilot would have to, I don't know, for example, wake up the pilot and say, do you think we should do this and that? And the pilot think, he look at the monitor and he said, okay, yeah, you can do this. And then the copilot would do this. Whereas for the actual type 1 hypervisor, which is the autopilot system, he will directly take action. So that's why it works very well for company working, real working environments. And the on the opposite, VMware, so type 2 hypervisor, it's very convenient for people like us who wants to experience stuff, who want to break things and repair and do and troubleshoot and do all of these things. Okay, so now let's talk about container versus virtual machine. Again, very briefly, we're going to cover this very quickly. So guys, VMs, each VM includes a full OS and application dependencies. This make them isolated but resource intensive, as you could so, because you see here I have, it consumed 2 GB. I did nothing. I'm doing actually nothing here, and it consumed 2 GB. Same for the router, same for the DC2. So, by the way, let me plug this. Let me connect to my environment. So it means that it's very resource intensive. So just I'm doing nothing and it already consumes 6 GB, and I only have 3 GB active right now. So if someone have an 8 GB RAM, it's going to be impossible for them to make this work. Whereas a container share the host OS, and it make them how can I say, it's it's making them lightweight and faster to deploy. You see how much actually you weren't here because I prefer to launch it before to start a live, but it really takes really much time to launch the DC2, especially that my DC2 has the FSMO roles, so the master roles of all the lab environment. Same for the DC1, it really take a lot of time. And maybe if I could show you here this thing, and I think you will really like it. Uh, let's say container. Yep. So guys, simply you just need to know that the actual VMs, it's this one. It means that you have the hypervisor here, and you have the guest OS. Okay. So let's say, for example, here it's the type 1 directly implemented to the hardware. So you have the hardware, here the hypervisor, and then you launch whatever host whatever OS you want, Linux, Windows, what you want. And then app 1 is, for example, Visual Studio Code, or I don't know, some apps that software developer use. And why I'm talking about this, it's because container, it's actually a lot for those people. Software developer use a lot of container. It's not our case, but it's just a way of explaining things, so you could have just a global idea of what container engine and the system, how it works. So you have the operating system instead of the hypervisor, and it control everything. Like it control everything. So as you can maybe already understand, it's less secure and less isolated. So yeah, maybe I could talk about that, and I could say, like, just as an analogy, imagine a VM as renting an entire house, while a container is like renting an apartment in a building with shared infrastructure like water, electricity, etc. And your VM has like the entire house for him. So what can I don't want to say this because it will not be fit to this analogy, but yeah, I'm just gonna stop it here. Like, I'm just gonna stop my analogy here, because I want to say stuff that are not quite true. Okay, no, that's actually true. The analogy could be good because when you have an apartment, you directly have warm water. You see, when you are in an apartment with a big building, warm water come quickly. But when you are in an entire house that you manage on your own, and you buy a house, warm water come very slowly. You have to wait. Okay, I made a good point. And it's exactly what happened here. What's happened here? I had to wait so much time for my DC2 to be on, and my DC1 to be on, so I could have my OS display. And it's exactly like in my analogy, when you have to when you have when you're when you open the when you, how you say in English, um when you just, yeah, oh, let's just say open the water, it will take so much time with when having a VM, so having an entire house. Okay, guys, so I hope this analogy was great. Let's now talk about VMware. So VMware, it's one of the most widely used virtualization tools. I highly suggest you to start with VirtualBox, because VirtualBox it's a mess. Like, to be honest, it doesn't work well. VirtualBox doesn't work well. There's so much issue. I don't know why, but I keep having I had so much networking troubleshoot to do, and at the same time my image was corrupted very easily. I don't know why, even though I still have this problem on my DC on VMware, but the difference is crazy between VMware and VirtualBox. But I still advise you to start with VirtualBox because it will give you the foundation of troubleshooting stuff, understanding what's the IP subnet, how the how networking system work in a global in the global, like just having a bigger picture of it, like an overview. Okay, so yeah, so if you are really a beginner, I will highly suggest you to start with VirtualBox and then going to VMware. So let's talk about the big misconception about the VMware interface. Let's start with the ribbon at the top. I see many people. I had, we had like many people that have this confusion that if you start doing things here or everything here, you are affecting these rebounds here. You are affecting every VMs, but it's not true. When you are, for example, if you are modifying things here, yes, you are touching to all of your VMs. But when you are actually setting stuff here, it's only to your virtual machine, not to all of the virtual machine in your lab environments. So yeah. Also, one thing that I want to add, the one that is quite interesting is this one. What do you think this is? Reserved memory. Sorry guys, I have to pause the video. I was actually listening to what I said here and I didn't like it. I find that my definition could be a bit misleading, and I actually have the best analogy and best example for you to understand it, especially for like people who are getting new, to VMware. And I think it's best if I rephrase it in a better way. And so, guys, let me say this, okay? Reserved memory, I'm gonna give you right now the actual definition of VMware, and you will see, because I did this, but it's not actually clear. I find it very misleading, and it doesn't really. I like when I cover stuff that really talk about everything in that topic, or at least to cover a large spectrum of this concept. Okay, reserved. So I'm gonna give you right now the definition of VMware, and you will see that is not that much clear. Reserved memory sets an upper limit on how much of your host physical RAM VMware workstation can dynamically allocate to all running VMs combined. Tell me if that's if that's clear for you. It's of course a bit confusing. I like more this definition. This definition is a bit broader, and of course it's correct. Like, it's correct, but it's just not that clear, So the reserved memory setting in VMware defines the amount of your physical RAM that VMware can reserve exclusively for virtual machines operation. It is a bit better. It's, like, gather a part of the information, but guys, look at this. I'm gonna give you the best analogy. Let's say I am running the worst coffee shop in my city. And you will explain why. In my coffee shop, I have big table with, let's say, bigger than this, with 24 seats. And if people know 24 seats, when I mean the analogy behind this, I mean gigabyte. That's my host's machine's total RAM. I have 24 gigabyte in this machine right now. It's true. I have 24 gigabyte. Okay. The VMware reserved memory is like saying. So the thing that you just saw, the settings. I'm going to set aside 10 seats only for my VIP customers, which is the virtual machines. Okay, and what I mean by this is actually here. Like I want like this seat, this seat, this seat to like not to be reserved, okay? Just to set aside. So that's why I'm the worst coffee shop in the town, because I'm so greedy. Like I just want money. So if people come, even though I have reserved this seat, I will give them, even though like they did not reserve, and then I will find out the solution. Okay, so so yeah, so here is the catch: you don't automatically assign those seats to specific customers. Okay, this is the catch. Like you only give them, so when I mean customers, guys, I mean VIP customers, okay? You only give them to the VIP customers and customers that just show up and need a seat. Okay, so what I mean by this is data. Like whatever data comes out, whatever apps comes out, he will take the gigabyte, and his place could not. So if a guy, for example, if a guy sit here, if for example some app that I'm opening, sorry, if some app that I'm opening and the app in my Windows here, for example, I'm launching Canva, I'm launching Google Drive, I'm launching Copilot that you see here, then he cannot be removed. Like this guy sit here and he cannot be removed, okay? So it is like the explanation behind this, and it's exactly what happened in your customers. If you are working with Canva, your Canva here, the gigabyte would not say, okay, don't, okay, I will switch off your Canva, and for that other machines gets running. It doesn't work that way. So if you allow it, I'm gonna explain it later why I'm saying this. Some customers, it depends on my settings. I could have some settings that, for example, there is like, how you call a waiter? Yeah, a waiter. For example, this guy here, he will welcome me. And let's say this nice guy here said, I have two options in my Windows machine. Here is how it works. When you are guys checking this box, allow some virtual machine memory to be swapped, what that means. Tell me what that means. Does anyone knows? So in this, when I check this box here, it means that this waiter is saying, okay, I can welcome you. I know you are VIP customers, so virtual machines. It's my gigabyte RAM. I can welcome you, but you can only have a seat. I only have room for you in the storage, the storage room. So like you need to be like, over there. Like it's another room. It's not the main room. It's some like other stuff that is not like the main how you say, sorry guys, the main room where all people are set, okay? So but, and this is when you check this box, it is when you check the box allow memory to be swapped. They have a seat, but it's far less comfortable and very slow to serve. So this guy maybe will come to the room and only like every 15 minutes, even though he already has an order in his mind, okay? So if you don't allow swapping, they simply cannot enter. The guy will tell him, please, we don't want you here. We already have enough customers. Okay, we don't have enough customers, and all the place are seats, and if it's going to cause so much trouble, okay, so that's why he will tell you, please do not enter. So now you understand what is the actual the actual definition of those settings that are right here, okay, that are right here. But it's not enough. You need now to understand like how reserved memory actually work in a better detail. So so let's say you set reserved memory. Now I'm gonna give you, the example of of an issue, so you could have like a great idea of what's going on. So let's say you set the reserved memory to 10 seats, which is 10 gigabyte. Like you have from here to here to here to here, so 10 seats. This is like your reserved memory, 10 seats, so 10 gigabyte, okay? 10 gigabyte. In reality, it's 10 gigabyte. But you invite, let's say you invite 6 VIP customers who all demand 4 seats each. Let's say they come with their family. That's 24 seats needed. But your shop only has reserved 10 seats. And let's say there is other people here. Like there is like many people here. So then you have like, let's say here, let's put like big family. So you have all these people. So you have like, for example, 4 people different and they all bigger. You see, like it doesn't fit. It doesn't fit. Like the waiter could not find any room for them. So so let's say this. It's better if I say this. They will not come all at once, okay? Maybe this family will come first, okay? Maybe 2 family, let's say the first 2 VIP, which is this guy is the VIP and he order for his family. This other guy is the VIP and he's order for his family. So they can get either 4 seats. So here and here. Let's say here and here. Okay, so there is only, let's say there's only this place that is available. So there is only 2 seats, you know, for the rest. But the problem is this thing. We have all this part of this family that should have a place. But we only have 2 seats here. We only have 2 seats. Okay? So, sorry guys. So, the other 4 customers, which are them, either they send to the storage room, okay, they will be sent to the storage room, so it will be slowed down by swiping, which is, and guys, sorry, I forget to mention this, when we say storage room, we mean SSD, okay, we mean my actual SSD, so that's why SSD is fast, but guys, RAM, it's way faster than SSD, okay, so that's the actual issue of this. So these people will be in the SSD room, and there is 2 options, like I told you before. They will be either sent to the, like I said, to the storage room, so it will be slower, or deny the entry. It means that we will say to these people, the waiter will come here and said, please, we don't want you here. Like simply, we don't want you here. We have enough customers, so please go back to your home and cook some, you know, like home cooking. So they will be denied. So the issue is that reserved memory limits how much physical RAM VMware can allocate to all VMs combined. Okay, it was the actual definition, and it's true. If it's too low, you won't have enough room to serve all your active virtual machine. If it's too high, your host machine, so the rest of the coffee shop, will have no seat left for other customers. Okay, so it is your operating system and other apps. If like I set an unlimited amount of memory, sorry, if I set an unlimited amount of memory, it means that for other customers, like simple customers that want to come here and just, you know, have a food or etc., they could not do it. So it means it will crash my this Windows here, okay? It will crash this Windows. So guys, now I just want to give you the recommendation for, let's say, 24 gigabyte. So in people that, or in my case, in 16 gigabyte. Okay, what I advise you is that to implement, let's go back. Actually, yeah. Here, guys, here. I'm actually mentioning this thing here. Okay, I recommend you to I recommend you to set better here. If you have, oh, let me use if you have 24 gigabyte, I advise you to have a reserved memory of 18 to 16. So like this, you will have 6 gigabyte to 8 gigabyte left for your host OS. Okay? In my case, I put it to 21, but I have to, because I was doing just some like configuration, and I wanted to test things, but I think I will go back to 16. I have better results with this, because even if all my 5 VMs are active, and they all have 4 gigabyte of RAM, which means 20 gigabyte. They never consume, you know, the full gigabyte. I have a SCCM server. That, yes, he consume really 4 gigabyte when he's active. Okay, but the other is like 2. You know, they consume maximum 2. So all my servers, they consume 4. So 4. So it means it's already 16 actually. But no, sorry, it's 12. Sorry. So here it's 12. It means that for my other 2 that I don't use that much, I'm actually, yeah, 16. So it is my other 2 VM. So it is my, like here you have 3 of my VMs, and here you have 2 VMs. So the fourth and the 5th. So that's a total of 16 gigabyte. So that's great. That's perfect. So yeah. Okay, so I hope you guys enjoy it, and now I will let you watch the rest. If you are testing like many stuff, you know, on your VMs, and you are about to do some heavy major changes, and you are troubleshooting, etc., it's better that you do a snapshot. Okay, it's better that you do a snapshot. So it's actually it's very weird, guys, that I use a snapshot. So yeah, it's here. So yeah, so you can use a snapshot for this case. Sorry, on this case. Now I have a question that many people ask, and including myself before, when I started using VMware. I just had a problem with like why VMware consumes so much. You know, that's why I told you, like, we will cover this later about virtual memory. But you just need to understand that because it's dynamic resources allocation, and actually no, dynamic means it's better because it's not fixed, it's not locked. But even though VMware dynamically allocates resources, the overhead of running a type 2 hypervisor adds a lot of resources, like resources management. It adds a lot for the Windows OS. And I have an assumption that because you need to know also this, that because it's on top of the OS, it means that the communication is pretty bad. Like it's not that great in terms of resource management. The host OS is have the competition with the virtual machine, and it also need to communicate with the hardware and telling him, look, I think I have some virtual machine here, so you need to allocate that and allocate this. But he doesn't have the right technology to communicate between this VM and the hardware. So if I could represent here, it's like here you have my VM, you have my OS here, and the actual hardware, it's like, sorry, let's lock this one. So it's like we have here the laptop, okay, and as you can see, all my VM is here. So this one is actually like the middleman between my hardware and my VMs, okay. So this one needs to communicate with the VM, but he cannot do it directly. He needs to first talk with my OS and say, sorry, it's the opposite. The VM here needs to communicate with the OS and tell him, okay, I need this, I need this, and then the host OS would say, okay, let me grab it from the hardware, and then the hardware will give it back to him, and the host will give back to the VMs. So it creates latency, a lot of time latency, we say. It like, just from my demonstration, you already know what could happen. The resource management is pretty confusing for the host OS to deal with it, to deal with all of this. Whereas for the type, of course, guys, I'm talking about the type 2. On the type 1, it works so it's really faster, and it know exactly what to give. Like for example, this, if he gives to the virtual machine, he know exactly he give 2 GB and he has 20 GB left. For example, in my case, sorry, 22 GB left in my case. So that's why the type 1 hypervisor, it's a very great tool. And the type 2, as you can see, it's quite difficult. It's quite difficult for the OS to deal with this. Okay, I'm going to ask the hardware to give me this, and then I'm going to give this, and the actual VMware needs a bit more, so I'm gonna ask to the hardware to give a bit more. It's very confusing for the OS. He is not set with the right technology to manage it very, very efficiently. But guys, it's still great. Like really, like the experience that I have with VMware, it's still great. Yes, when I have 5VM, and I'm gonna show you why it's great also. And it's actually a good transition for the the next topic, which is what install hardware for your laptop. But let me think, if I talk about every challenges. So we talk about the fact that running multiple VMs on the system with limited resource causes lag. So that's why, yeah, you could use Snapchat and everything. Yeah, guys, I think we cover like a lot of things on VMware, and it will be like the perfect transition for installed hardware. So I really love this topic, because you got to install components on your laptop. And guys, I'm sorry, it costs money, but there is no way, guys, that you have 5 VMs and you don't invest in anything. Like, it won't be possible. You have to first okay, before we dive in, let's just talk in general, about that. So when setting up a virtual lab, your hardware is the foundation, right? if you don't have enough resources like RAM, CPU, or storage, your virtual machine will struggle a lot, and your whole system too. And guys, I'm just thinking, I actually didn't talk about the fact, about my assumption that because of this that I just say right now, I think from if you keep using VMs and 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 use VM. So when I say if you keep using VM, I mean all the communication between the OS and the hardware, and because the host OS is not really fit for this job, even though virtualization is enabled, I think for the long time, on the long time, I don't know if it's correct to say this, it will break your laptop. I think that if you keep using VMs, it will actually break your laptop sooner than it should be. Okay? So yeah, so that's the things that I don't like about using too much VMs, using too much VMware is that it break my laptop. But your what I was about to say. So as you can understand from now, RAM, CPU, SSD, they are so much important. They are like, especially RAM. RAM is the backbone of multitasking. You see like all the thing that I'm doing here is because I have 24 gigabyte. With 8 gigabyte, there will be no way I could be able to do all of this. And I think even right now, I could maybe add one virtual machine and I could do stuff like maybe two virtual machine more, and I could do some stuff and still talking. But because I'm using my mic, I'm using the recording stuff, like like all of the metrics that are very task consuming. So that's why RAM is the most crucial resource for virtual labs, and it determines how many VMs you can run simultaneously and how smoothly they will perform, like I just said right now. And that's why you need to choose the right RAM. RAM is for random access memory. And what I want to take you, where I want to take you here, I actually have already here, maybe. Yep. It's this, like what you should buy. Guys, I'm gonna take you to the simple step of this. And what is the simple step? Guys, just go on ChatGPT, tell to ChatGPT your exact model. So you say, okay, the model of my laptop is a HP DH something, etc. And then it will tell you like, okay, because you know why I'm saying this, guys, when you are using not laptop but computer, they all have a standard size, so you can probably like buy everything. But when we talk about actual RAM, it's not sorry, when we're talking about laptop, implementing on laptop, because there is different size of laptop, and it's not that much standardized, so it could cause a little bit of issues. So sorry guys. So here you have, for example, mine, which is the DDR4, and here you have the setup. And also, guys, about the brands, I think it's important that I talk to you about that. I think what you need, according to me, it's at least 16 gigabyte. With 16 gigabyte, you can launch probably 3 gigabyte maximum. Sorry, 3 VMs, and it will work fine for you. Okay, it will work fine for you, I think, if you do this. And of course, guys, brands is very important. You need to choose, according to me, guys, choose Crucial or Corsair. They are for me like my go-to recommendation, because they are really reliable, and their performance is really good. And you need to avoid generic brands. Even though you may save some money upfront, but it will cost performance and maybe it could break your laptop. I don't know. I don't know. Maybe it could have some bad effects on your laptop on other components. So better if you use Crucial. So I know that it's like more expensive, but guys, it's something that you will use every day and for a very long time. So you don't have that much choice, okay? Um if you okay, no, I'm not gonna say that stuff. Then I want to talk about SSD. Guys, my SSD right now is probably already full, and I have one TO. I have one TO, and mine is already full. I have to clean up some stuff, so maybe I have to reduce it. That some VMs that I broke. Uh, so yeah, so I have to like delete. Sorry guys, I have to delete some of the stuff on my some. Sorry, some folders on my SSD. So what is this thing? It's an external SSD. You could buy an internal SSD and change it to 1TO. You can do this. I just prefer using external SSD. Many people they scare because they said they won't they the actual VMs won't be that fast. Guys, I'm sorry, but I was actually surprised. It's fast. Like my VM, they are not slow. For me, their performance, it's very fast. They are very quick when I launch uh, any processors, anything. It's like I'm using. It's like when I was using VMware without SSD. For me, it's really the same. Here you have one of the version which is 2000 MO. Me, I have 1000 MO, and it's do the work. So you don't need to buy this one that is expensive. You can buy the 1000 MO, and it will be enough. My actually my internal SSD is as fast as 1700 MO and is really fast. So in reality, of course, guys, just know this. They said 2000 MO, but it's not real. Like for me, they said 1000 MO, but when I go to my parameters, it's actually less than 1000 MO. It's like 700 MO per second. It's not 1000 like they said. It's like 7 to 800 MO per second. And of course, guys, you need to use the USB-C. I want to talk maybe a little bit about this. And guys, also maybe some people they said, "Oh, but I thought that the internal SSD we call it like HDD. It's actually the previous version of SSD. And one time I saw something about the differentiation between HDD and SSD. And guys, it's like HDD, it's like riding a bicycle to deliver you data, whereas SSD, it's like driving a Ferrari. And it's quite crazy that they said that this analogy is like true. So it's it's sorry, maybe I no, I it's not possible because mm, I don't know. I don't know if they say the right thing about that. If it's just like just an example and an analogy, maybe it's just an analogy, but it's not actually true. But if you take like for, I don't know, 2 centimeter, I don't know, just forget about this, guys. It's just an analogy to say that SSD is very fast. So, what is the difference between USB-C and USB-A? I think most of you guys know, but it's very important that you understand this thing because because of marketing, it's quite annoying. They lying so much about their performance and they will try everything to make them appear like they have um the fastest way of communicating, the fastest transfer data. Why I'm saying this? It's because look, here you will see 5 gigabytes, and here 2000 MO. And maybe you will say, and by the way, sorry guys, I just said before, what is the difference between USB-C and USB-A? And I didn't give you the correct the differentiation. So USB-C, it's, hold on, this one is USB-A, okay? This is USB-A. But right here, no, maybe here. Okay, maybe here. This one is the USB-C. And like I told you, USB-C is very faster. So when you look at this, you're probably gonna say, oh, but 5 gigabytes, it means that it's 5000 MO. So it means that 5000 MO is faster than this one. But it's not true. USB-C still faster than this one. Even though it may look like, if you do simply the calculation, the math, if you do the math, you would say, oh, 5000, it's actually, it's worth 5000 MO. So it means that it's better than this one. But you need to understand something, is that there is a difference between megabytes and megabits. And it's all that matters. Because again, it's all about binary system. All about 0 and 1 to transfer data. Okay, guys? So you say 5 gigabytes. It means that it's 5. It means It means that it's 5 megabytes per second. So I'm gonna type it here. You would have a clear understanding about what's going on. So I mean, just why it doesn't? Oh yeah, because I blocked it. I forget. I don't like whiteboard. So look at this, guys. So it will be better if I explain you this concept right here. I just went to grab my pen, so it could be very interesting for you. So guys, why I'm kind of go deep in that concept like that, whenever you have a marketing like type of strategy to make you buy this thing because it seems to be faster and you don't really look up to this, you could easily make the confusion and you could easily, you know, buy the wrong thing, buy the wrong component hardware or like this type of thing. So guys, here what we are talking about the speed. Okay, we want to know about the speed. We want to know about the speed. The thing is, if you want to know about the speed, you need to understand how bytes and bits function. Sorry if I say byte before, but I mean it's 5 gigabits, okay, not 5 gigabytes. So it's 5 okay, very bad, very bad writing. It's here 5 gigabits per second. Now what do you want? You want to convert 5 gigabits into megabytes. Okay, you want to convert into megabytes and not megabits, because what do you see here? What do you, okay, you see what did we saw about the crucial here? It was megabytes with a B like this. So whenever you see MB, it means megabytes and not bits. I will go into this. I will go into this, guys. 5 gigabits, 5 gigabits, it's 5,000, it's 5,000 megabits, okay? It's 5,000 megabits. And it's where a lot of people get confused because they see, sorry, they see that they will make like the small translation or like the small math, and they will say, okay, 5 gigabits, it's probably 5,000 megabytes, but no, it's only 5,000 megabits. How you make the real calculation is by doing this, guys. 5,000 divided by 8, and you have approximately 600 megabytes. And now you having the correct number of between this and that. And don't worry, guys, I will explain it. Between here, the 2000 MO. Now it's the real conversion. You see, it wasn't that easy. It wasn't that easy. Why divided per 8? Why divided per 8? Because simply, guys, bytes, sorry, I think some of you already know, but I'm gonna repeat here. I'm gonna say it. Bytes is 8 bits, 8 small bits. So 1 byte, it's 8 small bits. So when you have 5 gigabits, what do? You translate it first into megabits. You obtain 5,000 megabits, and you will see actually those sellers usually the marketing stuff is to give it into megabits. Okay, usually they give it into megabits. They don't give into usually they don't do this, but maybe it's a new strategy because they already use so much this. But if you see that thing, you need absolutely to focus on you need absolutely to focus here, guys. And here, is it in uppercase or not uppercase? If it's, or the thing is, for example, in our case here, they didn't mention it. They just said MO. But if you go to the details, normally they will add it. They don't add it, okay? But maybe it's because it's a way of calculating, and it will never be like 2000 megabits. So it means that you need to know, like you need to know upfront how the market is. So guys, it's very important, very very important. Same here, when you see B, it's not in uppercase, so it means that it's simply bits. And yeah, guys, so I hope you understand the way I explain it. So actually, when they say 600 megabytes, when they say 600 megabytes, it's not really true. It's not really true. In reality, so it's really crazy the way that when you unpack this, you are like so far from the reality. In reality, it's around 3 to 4 megabytes. When you really like, when you buy the stuff and you're using it, you will see that your actual hardware, it's consuming, which in this case the hub is consuming 3 to 400 megabytes. But guys, if you're not doing stuff like handling a virtual machine, it's enough. Like it's very good to have 3 to 4,000 megabytes. Now, okay guys, so I will wipe this up, because also why I'm talking about hub, guys, it's you need to know, and of course, guys, just one thing, because I want like to be as clear as possible. I didn't talk about this, but You guys already know, right? The differentiation between 1 mega and 1 giga. 1 giga, so 1 mega here, it's 1000. Sorry, my bad. Here 1 giga, it's 1000 mega. Okay, so that's why 5 giga means 5000 mega. Okay, so I hope that was clear. Okay, great. So let me delete all of this, and then after this we will cover. I will just, yeah, while I'm wiping this, guys, also buying a hub, it's very efficient for you, because you could have like many things on you. It's just like a suggestion. I just, because it's not that expensive, and I know that some of you already have like, some of you tell me that they don't have enough enough slots in their laptop, so you could buy at the same time of buying Crucial and your RAM, so you could, like, you could have a better, um yeah, just in case, like, just in case some of your slots, and it happens to me, like one of my slot doesn't work, so that's why it's important to have like this stuff. Also, guys, I know that some of you will make the mistake to try for searching. Sorry, guys, I just remember what is hard to find. You cannot find this, the one that we have here. Hold on. You cannot find USB-A plugged, giving USB-C slots. You will not find it, because the whole technology of C doesn't allow you this, and C is a newer, sorry, the technology of USB-A doesn't allow you this, and since C it's a new technology, so it will not work. But on the other side, you could find USB-C that is compatible with USB-A. You understand, like this here. It's a USB-C and it's compatible, and it's offering USB-A slots. Whereas when you have a USB-C, so sorry, when you have a USB, where is the, okay, it's before. When you have a USB-A, it's not compatible with USB-C. Okay, it's the only thing that I wanted to say, so people could have an idea about what's going on, and if they have like any challenges facing this issue. Okay, guys, perfect. So let's now discuss about page filing. Page filing, which is virtual memory used by your system when it runs out of physical RAM. If your random access memory is full, he will use page filing. Okay, I don't know if I can find a good image that talk about page filing. Let me search for it. Like some sort of images, like, I don't know if they have some cool images for people to, okay, very technical stuff. Unfortunately. Okay, maybe I could have like some, I don't know if I have some analogy for this. Yeah, maybe we could use this analogy that I'm using for this, but first let's break down maybe a little bit more what you should have before to explain that much the concept. So guys, if I could just quickly add some concept for this stuff. Page filing is something that is very useful when, like I said, your RAM is out of memory. Your RAM is full, so he will send a message to the SSD and say, please, could you help me to handle those files? those background processor or the processors, or those other files that are not really in using mode, like the actual host doesn't use it. And I want you to just keep in mind that I have this file, you know. It's like you're, like, I don't know, you're like doing many stuff with your hand, and you just like say, oh, could you hold that for me, like for a little bit, and then and then you do your stuff. And when you need back this one, you're gonna tell him to give you back the thing that you gave to this other guy. So it worked like this. And yeah, so if you have, for example, like myself, 24 gigabyte of RAM, your patch file should ideally be set between 36 gigabyte gigabytes and 72 gigabytes maximum. So 36 minimum and 72 maximum. And to adjust this, you need to go to system settings. So guys, also just note that the performance that I'm the space that I'm giving you right now, like the 36 minimum and 72 maximum, they are really meant for VMware use. Usually when you have 24 gigabyte, you just want page file to be 4 gigabytes. You don't want page file to be that much. Okay? So that's why the thing that I'm giving you right now, it's really fit for VMware use, because most of the time you will run out of RAM. You will not have that much RAM available, and it's always my case when even though I have 24 gigabyte, and I'm using 5 VMs, and I'm doing this stuff, and I'm setting up a server, and it really gets full very quickly. Okay, oh yeah, I was about to give you this. So the shortcut, sorry guys, the shortcut is just doing this. And now you could go to actually advanced settings and go to change. Okay, actually I made a mistake. You see, I put 96. 96, it's really too much. Okay, you don't need to give 96. So what you should do is to go here and do change, and you need to uncheck this box, because I know like most of you will have this box checked. So uncheck this box and push custom size, and you can write 36,000 as it's in megabytes and not gigabytes. If it would have been gigabytes, what we will have, right, 36, okay, and here 96 if it would be gigabytes. So, and then you just plug OK, and then your computer will restore it. I don't do it because otherwise I would lost, you know, my VM, etc., and I don't want that. So what is the misconception for that stuff? Maybe what I could say is that more RAM equals better performance. Many people say this, more RAM equal better performance, but not always. If your system isn't optimized, adding more RAM won't magically fix performance issues. Also, the thing that some of you said is that the more page file you have, and the more your system will slow down. Because imagine this, guys. You have your RAM 20. Why it's that heavy? You have your RAM here, which is, I don't like that one too. This one is good, and I like pink, yellow. So you have 24 RAM gigabytes. You have 24 gigabyte. let me check. Yeah, you have 24 gigabyte, and you have a page file of 36, which is a lot. Like you could go on Google and say what they recommend. Usually they recommend, like, for example, 4 gigabyte. And when you automatically give the resource on the thing that I just showed you, like the system properties, system settings, they will tell you that 4 gigabyte, when you set it to automatically, will be the average. Like 4 gigabyte, 5, 6 will be the average. So 36, it's a lot. The more page file you have and the more your system will slow down, will not be fast, simply because you are saying to your host, to this host here, whenever, like, that he have so much place here that he could use. So he will so the actual host will give then many file to this page filing. He will give him many things to do since it has too much place. And maybe this one is struggling a little bit, like it's going to 8 to 16, and then it go down, and then it go down to 10, then it go down to 20. So all these things make your system more, like, your system will think about giving more and more places to the page filing here, because simply it has so many places here. But here it only have, for example, here, okay, it has a lot. It has 16 left. Okay, it has 16 gigabyte left here. Then only 8. Then only 4 gigabyte left. And because your everything is dynamic, and he always in a way to prevent a critical issue of having no RAM. So he will use a lot of page filing if you set a large place in here. So what it means that your system will slow down a lot. So he will just have slow performance, but he will handle perfectly heavy workload. Okay. And now if someone wants like a better understanding of, again, what is page filing, if some of the people, they still don't get it, but I think you already got the actual meaning of page filing. And guys, it's actually a place in your SSD that you could go. I don't remember exactly where it is, but it's a place in your folder, in your file explorer. So what I mean by this, it's uh, yes, so it's a place here in your Windows C, and you will see like page filing. And the more you add some places, the more it will use it, you know. And so it means that you need to be careful, because you could have for example, here you see I have 120 gigabytes left. It's not that much. And you see, even though I have 1 TO, I only have 3,300 gigabytes left. So that's why, by the way, guys, I forget to tell you, but it's good if you also buy like another one. Because if you buy another one, so like this, you could do a lot of, you can proceed to a lot of backup, you know. And guys, it's so much important, like to backup, you know, like any of those type of files, especially when we talk about yeah, virtual machine, images, etc, etc. So I think that now, I hope you guys have a clear understanding of what is page filing and how you could configure it. So now let's talk about key concept of Active Directory, and we are going to illustrate what is an Active Directory. So think of an Active Directory as this, guys. So let's put building, and we're gonna use okay, but I need also another thing. I need also this. Yeah. Okay. So, okay, look, guys. Let's just imagine that in order to go to the building, there is a nice guy that where we have to show them the badge, like show them that we are part of the companies, okay? And he's here checking everything. So I'm just like setting up the actual introduction of it, the actual context. Sorry, it's a better word. So, guys, think of it. Think of Active Directory as the HR department of your company, where it keeps records of all employees, like, I mean, users, their roles, the permission that they have, like in our case, for example, the building that they could go, the building where they cannot go. And if we are saying that here it's the, for example, the Active Directory, and so here it's the AD, and they have the people that work here, they are like the AD, and they have control over everything. Like they have the control of this guy here. And guess who is this guy? I said that AD is like the HR department of your company, and it keeps records. So in this building you have like all the cabinets, the file cabinets, where you have all um the employees files, employees profile with, okay, this guy's from there, he lives at this place, and when he go to the building, he we give him the his pass, and the password of his pass is like 349, etc, etc. So so what do you think about this guy? Who could be this guy? This guy is the actual domain controller. This is the security guard of the whole building. It checks everyone badge, which is login credentials, and allows or denies access based on the HR records. So this guy is on the phone, is always, imagine this guy always on the phone with the people from here, and saying, for example, let's say we have, let's put nice guy. We have this guy who trying to go, he's trying to go there, like to the building, and him is telling, okay, you want to enter to the building, which is the domain controller, as I explained, is the domain controller, and he's explaining, and he's asking, okay, could you show me your login credential, and then I'll let you in. So that's why I have many people in the, many guys in the community, when they, I know that many people have this issue, not only the or guys in the community, but they tryna log in to their virtual machine, but they can't because their DC is not on, and they think that they have a big issue, that something is bad, and that they have like a big issue on their lab environment. But not, but it's not true. You just need to have your DC always on. Your DC always need to be active, okay? And because if this guy disappear, then the Active Directory cannot control you. He cannot control if you are a nice guy or a bad guy. He cannot know if you are part of if you are part of the company or not part of the company. So that's why you need to have your DC enabled. Otherwise, this guy here won't be able to, actually to go to reach the company. So it's a very, very important. I never saw this actual analogy in YouTube. Really, I never saw this analogy. If someone could have explained me this way, it would have been so much better for me to understand what is Active Directory. And here, what you see here, guys, all the structure, it's the actual, like the laptop, your laptop, the hardware, the VMware. It's all of this thing, like the structure of the building. And here, it's the HR company, it's the HR department, it's the AD. And again, sorry guys if I'm repeating, but it's really for, like people who just know about this analogy, so it could, they could have a better understanding of it. So this AD again, he had all the file, all the registering access of everybody in the company. He knows everything, and if you are not, for example, on this building, he will not give you access. Like if you want to go there, you don't have the access, he will not give you. He will not give you the access. So what is the analogy here that I'm giving? It's actually the file permission. You see, if you are, for example, a simple employee with domain user, if you are in the domain user, you won't have access to everything, right? Because you're just a user. For example, if this guy here, is just a like we'd say this guy is a trainee, is a intern. He will have he couldn't go to any of his building, to any room that he wants. He will just maybe be in the marketing department. He will just be there in the marketing department. Whereas the actual IT guy that has been in the company for over, I don't know, let's say 10 years. I don't like that much this picture. This, okay, it's fine. He will have access to everything. Like he would almost, like, let's say the system admin. This guy is a system admin. He will have access to everything because he's not only part of the actual, is not only part of the domain user, but is also part of domain admins, which give him super rights, like super admin rights. And sorry, I don't have my pen with me. Let me try my pen if it works better this way. Not that much. Okay. So okay guys, that's great. So what can I say more? So yeah, so like I said, this guy had access to almost every room and every building of the company, compared to this intern who only has access to one room. Now the other thing that I could say is that I think that's all, right? I can talk also about forest. Yeah, it's a very, very important topic, forest. I know, again, so many people, they get confused about that, and I'm gonna simply explain it through my analogy, which is a great analogy. I'm not gonna lie, I really love this analogy. I think it's the best way to understand what is Active Directory. So let's simply, sorry, let's simply quit this one and say that, yeah, it's when you do fast, like when you try to do copy paste fast, Canva doesn't like it. So forest, guys, it's actually it's this. It's, you have a domain here, Paris, we can call it like this. I'm trying to use, you know, my pen, but it seems to be a bit hard with my pen. I will try again. So this building is the Paris building, okay? This one is the, I prefer to say this one is the Lille building. This one is the Lille building. And this one, for example, is the Lyon building, okay? It's another city in France. So, actually, what I was about to say is that, oh, yeah, of course, it will not match. No. Let me go back to this. Let me go back here. So, everything that you see here is the actual forest. As simple as that. Everything that you see here is the forest. Okay? And in my case, I have another domain controller in Lille. And this guy is taking care of the people in Lille. And I call it DC1 Site 1. DC1 Site 1. So DC1 Site 1. It's, yep. And the other one is DC2. DC2. And maybe in the future I can maybe add a DC1 Site 2. Okay, and it will be in Lyon. So, and Lyon is a beautiful city like Lille. So why not implementing another site in Lyon actually? And so just for people to know, as you can see here, look, DC1 Site 1, okay, Lille, DC2, and it's Paris. So I'm actually representing my actual domain, but visually. And I think it make more sense to do this. For me, it's really make more sense than just talking and trying to say that, oh, Active Directory is a centralized directory services used by and it's the backbone of, like, it's too much. It's too much. It's better if you do a visual representation of what is your Active Directory. And again, you have here the HR, the HR is there, but actually, let me think again. Let me think of my analogy. You need to understand also that you have one big FSMO, and in my case, it's this one. In my case, it's this guy. This guy is the FSMO, but maybe we'll cover this later. Let me check. Yeah, guys, just before we talk about this, I want to also add three other things, sorry. The first one is the domain. What is the domain? My domain, in my case, here, it's this. It's, sorry. In my case, it's, and I didn't want to implement another domain, you know. I could have put like lil.int.security, paris.int.security, but I decided that I want to have every of my site under int.security, and we're gonna look at it right now. So, yep, here, and okay, I'm just checking this. Sites. So remember, guys, here we are in. Oh no, actually, we could go to user. So you see here, my domain is nt.security, and if I go to my DC2, it will be exactly the same thing. It will be it would be anti.security.com. So there is one big domain with two sites. Okay, I could have did paris.anti.security.com, lille.anti.security.com, but to be honest, it's a mess. Like, it's very complicated, and I think even company, they don't do this that much. They keep one big domain for everybody. So it's the domain, not the forest. The forest, I think my forest is yeah, I'm pretty sure my forest is anti.sec. My forest is anti.sec, so it means that it concerns like the whole like the definition of forest is actually it actually means multiple office branches. So this office plus this office plus this office. But in my case, like, I didn't want to have deal too much with details. I add this domain for everybody the same. So domain and forest could be confusing in my case, because I didn't want to add a subdomain into it. So, but just keep in mind that anti.security means all office branches. For example, your company may have, like I said, an office is in Paris, Lille, Lyon, all part of the same all part of the same hierarchy, you know. So then, what is the domain? The domain is each office branch, like each office branch is a domain. In my case, anti.security.com. So this domain manages its local user and computers and resources. Okay, so I hope that you guys understand. It's just like what I just gave right now is like the generic definition of what is a domain and what is a forest. Okay, so next thing I want to talk about that. I want to talk about organizational units. Organizational units, which is OU. Everybody call it OU, and OU, it's this. It's like departments inside the office. It could be HR, IT, for example. In my case here, it could be the IT departments at the top, the finance here, the marketing here, the like everything. Okay, here the marketing. So yeah, so here same, you have the IT here, IT department, marketing, finance, etc., sales. So this is the actual organizational unit, the OU. These are like departments inside the office, and they help organize resources logically. So for example, in my case, I have this. In my case, I have this. If you look here, again, we're gonna go to active. In my case, OU is Paris, you see, and the other OU is Lille. So why? It's because, like I told you, I didn't want to do this. And actually, also other companies, sometimes they keep everything under the same domain. But if you are like a big company, let's say you are a very huge company, yes, you're gonna have paris.security.com, and then you will have sales, HR, IT, marketing, etc., etc. But in my case, like, let's imagine I just have 500 employee and I have 2 big sites or 3 big sites. I'm not going to have like a big multiple domains. I'm just going to keep everything under anti.security.com. So that's why here I have Lille. It could be counterintuitive, but it's how company manage it. So And here you have domain controller, sub SCCM, we're going to talk about this later. And in my Paris, it's here that it's like the real OU, okay? Like help desk team, let's say it's the guy that managed the SCCM, here science division, if you are working, I don't know, in a lab, in some sort of scientist lab things. So yeah, so it works that way, guys. It works that way. Now, what is a DN? Distinguished name. Guys, just think of it as the postal address for any object in AD. For instance, I told you that we talk first about AD, then DC, then forest, then domain, then OU. So we went like this. We went like that. And the last one that is the little part of AD, we call it DN because it's the where your object is located in AD. The best example and the very simple example is users. For example, we have this guy here. That is the intern of the Paris site in the marketing. And when we look at this DN, we will see this. We will see that. We will see this guy will be like this. It will be CN. Let's name it Luca. Shout out to you, Luca. Is here, right? Let me check if Luca's here. Okay, he didn't left. He didn't. He stayed. He already was us. He stayed with us. Okay, so yeah, so CN equal Luca. Luca. I'm not gonna say your your real name, but let's say Martin. OU will be marketing, and it's exactly what you're gonna see if you. I'm gonna show you it later. And then DC will be antidote, and other DC .com. I'm going to type .com, but just I need to check some other thing here. Let me just check if I do it properly. Yep. Okay. So yeah, DC in uppercase. Oh, sorry. Yes. Yes. DC equal antidote. DC uppercase. And guys, DC it's a domain component, right? It stands for domain component. So yeah. So here is the actual DN distinguished name of Luca. CN common name Luca Martin. OU organizational unit, and DC domain component, and antidote, and the other domain component is .com. So just com. Okay, so for example, if we look here and we try to do this, okay, and we're gonna do the simplest command line on PowerShell, which is who am I .fqdn. And guys, it's exactly the same thing. So who am I? It means you are, in our case, not Luca, but in my case, we are talking with the DC2. So the big admins controller, we call it FSMO, and is the administrator, CN administrator, OU domain controllers, admins, okay, OU Paris, DC, antidote security, com, etc. So it's where the actual object is located. Great, great. It's very great, guys, that we are here and we cover all of that thing. You guys are have lot of courage. So now, what about my lab environments? I told you that I have two sites, but I want you to look at this so we could erase that. Now I want to show you more a little bit, and we're gonna do a little transition. It will be a perfect transition to the second thing. But I just remember that we have so much to cover, so we are still not done with this. But just keep. Oh, yeah. I said we're going to stay with this. We're going to stay on that part for a little. Oh, I already have it? No. So as you can see here, my Paris site is here. And it's going to be interesting if we look at what is my actual IP address. As you can see, my IP address is this one, 0.19. Okay, this is my subnet here, subnet. And what identifies my laptop, this device is 0.19. It's where my DC2 is located. So, and here is the site. It's Active Directory site and services are where your actual sites are. And I'm just thinking if I'm going to talk about this, or I'm gonna leave it for like the next stream. Okay, I prefer to let it for the next stream. So yeah, so each site, as you can see, has its own domain controller. DC2 for Paris and DC1 site 1 for Lille. And Paris uses the subnets, as you can see here, this one, but 0.0, so no 19 but 0.0. And for DC1, you see the actual same. It's going to be yep. Is sorry, it seems that I'm getting a little bit tired. Okay, we're gonna keep the energy up, don't worry, guys. This or not? Yeah. So here, ipconfig, and my domain, as you can see, is on another domain, is on another network. So we have this network and this network, and what make the connection between this? It's my router. It's this one. It's this VM that make the connection between this one and this one. But we will cover this later, and it's going to be so important in order for you to have a clear understanding of networking and the very basic of it. So you know what happened to this one, to this domain controller? Actually, nobody called it DC2, like nobody started with DC2. So most of you know, but I lost my DC1 because I had some image corruption. Yeah, for my DC1. So you know what? Of course, it forced me to demote my DC1 and transfer all FSMO roles to DC2 in Paris. And for the one who asks what is image corruption, in virtualization, an image is a snapshot or file representing your virtual machine's operating system and configuration. Image corruption occurs when the file is damaged due to the reasons like power interruptions. If you suddenly abort everything and turn down your laptop without doing anything the right way, the safe way. It could be a storage issues, and it could be a software bugs or improper updates. In my case, to be honest, I don't know what could cause the image corruption. So I'm gonna also advise you something that is very important to do. But before, I just want you to know this, because I said before that my DC2 is now my FSMO, and it's very important that I tell you what is FSMO and why this one is not a FSMO. I'm gonna first tell you what FSMO stand for. It's a roles, and it stands for flexible single master operations. It means that is the big guy of your network. If this device turn down or have any issue, your system will have issue. And that's why I'm very scared. That's why I'm very, very scared. I hope that this laptop will not have any image corruption. But there's always a solution. What you could do if you have any image corruption, it's, by the way, the next thing that I'm gonna do is create a DC3. You create a DC3, so whenever things happened in Paris, you have another DC, so you could transfer all FS, so flexible single master operations worlds, to the DC3, and then you can demode the DC2 like I did with the DC1. So yeah, it's it's not a joke, to be honest. It could really because some people like me, like you have been building this lab for a year, or you have, like, I don't know, you have did some stuff, then deleted, then build another thing. So yeah, but we're gonna cover this much on the next stream, and it's going to be very, very interesting for you guys. So also, one thing that I didn't talk about Active Directory site and services, it's of course replication. Most of you know, but in order to have the same data on the domain controller, the same Active Directory data, you need to always replicate those two servers, those two DC, which the replication, what it does, it actually replicates all the file, let's say file cabinets, like all the file present on the DC2 is replicated to the DC1, is going to replicate to the DC1. For example, right now, I'm going to create a user in the DC2. In order for the DC1 to get sync, you need to replicate, and it doesn't happen like this. You need time, so you will replicate, and you will wait maybe like 3 or 4 minutes before to do anything. So yeah, so good. What can I say more? Yes, guys, I talk about this like so many times. I talked about this so many times. You need to have images. And you can look up on YouTube what is images and how to set this up, but it's very easy. You basically create your Active Directory Windows Server domain, or your Windows 10. It's going to be useless, but you just create a Windows. But I suggest you to do all. No, sorry guys. Windows 10, Windows 11, Windows servers, they're all very, very important. So I was just thinking about another thing, but please keep in mind, all type of Windows you have, version, no matter the version, please do an image of it. What I mean by image, I mean this. If you go here, and you would not actually do here, when you want to create an actual Windows server or Windows 10, you will probably waste I would say 30 minutes to 1 hour. Depends on your laptop, depends on many things, but easily like half hour just doing things that you could have do in just 5 minutes. I will explain you. If I want to create a new virtual machine, I will go to this step and follow each things, and if someone doesn't know, he will look on YouTube and trying to copy paste everything. By this method, guy, you just go there, image Windows Server here, and you just follow, and you have it. You already have it. So the work is already done, and you don't need to do anything. Of course, if I power on the machine, I would need to go to some very, very few very few thing, which is adding this device to the network. But just that, guys, just that. You don't, guys. If you never did like any of this if you don't have this implemented and you don't know what is it like, guys, just to arrive to this point is minimum half hour. So that's why it's so important for you. And some people, they say, oh, but I will not need, I will not have any file corruption, I will keep my VM forever. Yeah, it's, yes, guys, it's, we all want this, we all want to keep our VMs forever, but it never happens. Always something happen. I built maybe 3 to 4 SCCM in a very, like, in a small amount of time. When I say small amount of time, I mean, I don't know, maybe like 4 months or things, because I was like helping others with this. But yeah, and so you could set a SCCM. I don't know, things doesn't work well. When I say SCCM, I mean server. Like, it could be a email server. Maybe if I say email server, people will better understand. I built my email server, and it got corrupt. I don't know why. It really didn't work like it's supposed to be, like it's supposed to do. So I just changed it very quickly. So it's what you need, guys. Then I think it's all, guys, on this part. I think we cover a lot of things. So yeah. So tell me if you have, just write down your question, and sorry, I forget to say this for every part. But guys, for every part, don't forget to add your question. I know I'm not perfect. I don't do the best lives, but I try my best, and I know that we need for sure to cover questions later. So that's why we have planned the Q&A. Okay, so let's go with the next topic. So guys, now networking. I told you that it's going to be the most important topic. I don't know why I let this topic at the end, because my energy still needs to be up, and it's quite hard, I'm not gonna lie. So, but don't worry, I have enough energy to finish this topic. I really love that one, because at first I didn't like networking, but with time and just learning again and again those concepts, because the problem that you will get when learning new stuff is that you will go like this, and then it go up. So it means that you will start to learn new concept, then here you will forget about this, you will forget about this concept. So you need to put energy, but less energy than here, less energy than here, so you can gain back this knowledge that you forget, and then reach another level, and then again, etc. So until like when you hear, like, you're really liking it, like you start to liking it, because you're putting less efforts, you're putting less efforts. And also the connection here is like better, like you feel, you start to connect things here, and it start to make sense. So you start to say, oh, but actually, yeah, like, I know why I learn about that is because of this. So that's why now I start to like networking, and it's a journey, I'm not gonna lie, it's really a journey. So guys, networking, we are agree that is the foundation of modern IT. People said that it's the invisible bridge that connects devices, application, and users in homes, businesses, and across all the world, all the globe. So that's why you need to understand key networking concepts, and it's what we're going to do. So we're going to start with bytes, bits, and the logical behind IP addresses. I will explain this one just like later. It's really going to make sense, because everything lies to this. Then OC model, you will love the analogy that I have for you on this topic, followed by switches versus routers. Many people get confused about that. IP addressing and subnetting, networking topologies, And finally, addressing the critical role of DNS in networking. This one is like just the fun, you know, like it's the end. So it's going to be only a small part. It's not going to be a big part. So yeah, guys. So we're gonna cover a lot. I'm sure you will love it. So that's why each section will be tailored to help you understand not just the theory, okay, but also how it applies to real life scenarios, including my own lab setup. We'll see stuff on my own lab, and I'm gonna show you some stuff too. So what I want to do is to go. I can't. I want to go there. Yep. So what we will do is that we will delete everything here. Um, we need to do this because it's a serious topic. This one is a very serious topic, and I want to show you things. I want to show you things there. Um, so guys, at the heart of networking is data. Okay, we are all agree on that. Networking is data, meaning it's only bits and bytes. Your computer only understand this. He only understand 0 and 1. He doesn't understand anything else. He doesn't understand your text message, the colors, the actual video that you sent to your friend, the nothing. He understand none of this. None of this he could figure it out. The only thing he could figure it out is 0 and 1. It means that networking is only based on 0 and 1. And I need to cover this very fundamental concept because otherwise things could be like you would have some question, some interrogation about why is working that way. And especially with networking, you will see why. You will see why it's so much important to cover this very basic of 0 1 0 1 0 1 0 1 and then 1 byte, etc., and those combination. So a bit is the smallest unit of data, and it can be either a white it could be either a 0 or a 1. Okay, so let's represent by those 1. Where is it? Okay, so this bubble here is a bit, okay, and 1 bit is just a combination of either a 0 or a 1. What combination you could have with 1 bit? 1. Only 1. Either, 2. It means either this light open, or either, or either 2 of them are on. Okay, not open, sorry. 2 of them are on. So it means that here we have, let me use my pen. Here we have 2, because we have 2 combination. Either this is white, or either both of them are on. Okay, so it means you have 2 combination for 1 bit. Okay, sorry if I say byte just before. I don't know if I make the mistake, but no, 1 bit, 2 combination. 2 bit, 4 combination, because down here you have this. Let's use those 4. For example, you have this combination, or for example, you could have, my bad, you could have this combination, Or you could have, let's say here, you could have I already did it, so let's do this combination, and we can also have this combination, so it means 4 combination. And when you go until 8 bits, it means you have 256, if I'm not making any mistake, 256 combinations. It means that from, hold on guys, from 0, and by the way, 1 byte, it's 8 bits. So 8 bits here, this one here is 1 byte. We always put an uppercase for 1 byte and a small, I don't know how you call it, but a normal case for the bit. So, okay, when you have 1, 2, 3, 6, 1, 2, 3, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and 8. Here you have, okay, here everything is 0, right? You don't have anything. Now the maximum combination that you could get to reach, it would be better if I do this way. Now if we go to all the combination possible to reach this 1, 1, 1, 1, 1, 1, 1, 8 times, it means that we went until 256 combination. For going to no combination and then going, so 0 bit 0 bit to 8 bits, so 1 byte, you went into 256 combination. So here I say 2 bit 4 combination. What is 3 bits? 3 bits is I don't want to make any mistake because it's live, and if I do any mistake, people will be mad. 3, it's 8. Okay, 3, it's 8. 4 bits actually, sorry, 2 bits, 3 bits, 4 bits, it's, can someone, I'll let you think, and it's actually 16. It's 16 combination. And when you go, for example, let's say 7. Okay, no, I will continue. 5 bits, it's actually, and guys, to help you, you do 2 exponents, I think we say in English, exponent equal to 32. Okay, it's 32. And now when you say 6 bits, it's actually, we're gonna type it here, 64. Okay, 7 bits, so 64 combination. Okay, 64 combination. So from 0, 0, 0, so from 0 bit to 6 bits, you have 64 combination. And then 7, you have 128 bits, and 8 bits, finally, you have a total of 256 combination. Okay? So it's very important that you know about this stuff, because otherwise it could be, it's really the foundation, guys. This thing you need to understand. You really need to understand this concept. So why I'm explaining this? I'm explaining this because IP address is only about that. It's only about that. It's only about you have here, for example, my net. Sorry, I need to do this before. Oh, sorry. Okay. It's only IP address only about bits and bytes. What I mean by this is that, for example, my IP address is 192, 168, I forget, 57, and 19, for example, okay? And here we say 32. I will explain you later why we say here 32. Okay? I'm not gonna explain it now. Why it's only about bits and bytes. I'm gonna explain it right now. Do you know what is the possibility of here? Why it's 192? Can it be, did you ever see a network that is 300, that starts with 300? No. Did you ever see a network that is minus something? No. You only see range from 0 to 255. That's a bit weird, right? It seems that it's 8 bits. And yeah, it's 8 bits. You actually got it. It's 8 bits. So it means you have 4 ranges, 4 sections that are actually only 1 byte. So 8 bits. Here same. 1 byte. 8 bits. 1 byte, etc. 1 byte. So it means that all of the ranges here, all of the section could only be between 0 to 255 because it represents 256, and in IP address 0 counts. It counts. So that's why we say until 255. And in total, you have how much bytes you have and how much bits you have. You have in total here 32 bits. So now we get why when you always see one device IP address with this notation. Now you get the point. We see 32 bits. We see 32 because it represents the total number of bits that is used in the network. Let me go for that. And what is CIDR notation and network address? So it's basically where your network is located. We need to know, like network engineer, they need to know where your network is located. And what is the range, okay? Because if someone come, of course the DHCP will send them an IP address. You know, like the network is living. The network is really living and is allocating resources, giving IP to everybody that come to the network. So we need to locate this network address, and by doing, and so when I talk about network engineer, it's because they are managing the network. They need, sorry, I just mute without purposes. I said, yeah, network engineer need to be aware of what's going on in your network. And the simple question that comes in first instance, where is your network? Where is your network located? So how we deal with this, it's simply by having this. I'm gonna show you right now. Here we have, for example, in my case and in VMware, you will see that it's called IP subnets. But in the working environments, it's not IP subnet, it's just network address. It's where your network is located, okay? But I don't know for what reason, but because it's isolated, then VMware in your virtual editor in here, I will show you if you want. View, edit, virtual network editor. He will told you subnet IP, okay? But it could be counterintuitive, and I will show you right now. Yep, I will show you right now. So look, you have here, where is my, hold on, let me take my pen. My network address is located here, okay? It's where my network is, sorry, it's, hold on, it's where my network is located. It's here, okay? So it means that from, by the way, it's the most important things. It's really the most important things, what I'm going to do right now. And I'm going to explain it later. So /24, it's the actual CIDR notation. And the aim of this network here is to, like I said, locate the network and explain the IP ranges from where to where. What is the beginning of your IP address, and what is the last device that could enter your network? What is the finish line? So the finish line is, and I'm gonna explain it later why, it's from this 0, this is the beginning, okay, beginning, to 192, 168, 57, and because we count the 0 as we see before, until 255. And why we know this, why, for example, like if I see this, I will instantly say, okay, it goes from 0, it's the network starts from here, and it go from 0 to, it go from 0 here to 255 instantly. And how I know this, I will cover this right now. So from, look what we covered before. We said that here it's 8 bits, right? Not bytes. It's 1 byte. But by the way, let me check. Yep. 8 bits. Okay. Here, same 8 bits. Same 8 bits. 1 byte, 1 big byte, 1 big byte, and 1 big byte. And here it's 8 bits or not, because it's 0. It's still 8 bits, but you will understand what's going on. This one, from here, from here to here, we have 8 exponent 3, which is, we have 3 8s. So if people don't like exponents, we will just write it like this. We have 8 multiplied by 8 multiplied by 8, which is, if you remember your math class, 24. 24 what? 24 bits. What this number represents? Kind of look the same than this one. So that's why it's so much important. CITR, it's so much important, and knowing what is a bit, what is a byte, it's also very, very important. It's because of this, guys. Because like that, you could say, okay, an IP address have 4 bytes. Each byte is 8 bits. It says here 24. So it means that the first byte here, the first byte is covered by the network address. Sorry, network address. I just want to wipe. Oh, okay, it's fine. The network address is covered here, but hold on. The first portion, 1 byte, 8 bits. Second portion, 8 bytes, 8 bits, sorry. So 16. Third byte, another 8 bits, so 24. So what I'm gonna say in my head, okay, I stop here because this is where it's located. This is where the network address live. Then here, what is it? You are actually giving this port to the host, to us, devices employee. You're giving this port to your employee. So the DHCP, when it's going to deliver all the new IP address, he's gonna give this port. So this one is where your network address live, but here you are letting this to your host, okay? So when we say 24, we are actually leaving 8 bits for the host. So for us, for the employee, for the devices, the laptop, your phone, IoT, Internet of Things, we are giving all of these things here, okay? And what does it mean? You have 256 combination. So it means that you could add up to 256 devices. So if you have, for example, 30 employees, multiply by 5, because imagine they have a laptop, one have 2 phones, and we could say that, for example, you have many IoT. Okay, you have many IoT, many small devices that are linked to, like, let's say, security camera, all of these things. So it means approximately per user, we have 5 devices. So it means you have 500. So it's still okay. So if you are in a site with 30 people, you have and they all have an average of 5 devices, it means that you have 150 you have 150 devices that are registered to the network, okay? And what left? How many left you got? I'm gonna let you do the math, but it will be 106, right? 106? Yeah, because it's 256. Yes, I'm right. But no, I'm making a mistake. It's 5. You see? I made the mistake. Maybe I did it on purpose so you could figure it out and learn better. Because it's really with this kind of mistake that you could learn better. So yeah, so it's 105, not 106 that is left, because we count the 0. But actually I didn't say it. Because I say 150 device. So okay, let's do it the good way, okay? Even though it's not planned, 150 device register in this network. In my network, for example, I have a site, and in my Paris site, I have 150 devices. What will be the number here? On the host number, what will be the host number? the host number will be 150 or 49. Yes, it's going to be 149 because we count the 0. Okay, and then it's actually, even this is not really true because you have like places for the network, places for this, but it's just a way for understanding that it's just a way to understand that the 0 counts. So it means that you could then add you could add then 156, right? You could still add 106 devices, because you will reach then this plus 149 plus 106, it's 255. Okay, so guys, this one it's really important. I'm telling you, this what I just covered right now to understand networking, it's so much important. I was about to go to another subject, but I just realized that we need to cover another very important things. And this important things is IP subnets. Did I told you that the IP address that you see here is perceived for VMware as a subnet? I don't know if I told you this. Sorry, it's a long life. It's very long life, so I kind of forget. But I'm sorry, I'm starting to forget. Okay, so here, Imajan, we live in a real company's environment. This is the network address. It's where the network address is located, right? It's where the network address is located. So we need also to talk about a very important stuff, which is IP subnet, because in most company, network is divided into small portion, and they do this for efficiency, like efficiency of IP efficiency, IP management. It's how we call it. So it's to avoid first wasting IP addresses, and also to reduce congestion. So it limits broadcast traffic to this within the subnets. Okay, and also they do it for security, because if, for example, you have the marketing team located here, IT team located here, it's very important. So what is IP subnet? And like I told you, IP subnet it's an important notion. So IP subnet and you have also subnet mask. But do I want to talk about that or not? No, it's okay. I could touch on it just a little bit, a little bit. Okay, so what about IP subnets? IP subnet, it's a way, like I told you, to divide your network. Guys, I'm just going to give one example and that's it, because it's the only thing you need to know. You have here my network. Here it's my network. We have, I said, 256 combination, right? Let's say I have only two. I have in my network, I only have two departments. Okay, I only have two departments. The first department, the first OU, let's say the first OU, organizational unit, is sales. Okay, and this one, product. So the one that do the product and the one that sells the product. Okay, so very simple company structure. So we want to keep things secure, efficient, and reduce congestion. So the sales team have a very good subnet that go fast, etc. A very good network that go fast. Same for the product team. I would say it's it's very important for the product team to have a subnet. So what we are doing is that we are actually splitting the IP subnet. So this is the work of the network engineer. So we will just cover what you will see, like when the network engineer will come to you and will talk to you about what's going on in the subnet and what is the network topology. We will see this later, which means how your network is structured. He will tell you this. Okay, he will show you that 192.68.57 57 slash, sorry guys, 0 if I'm not mistaken, slash 25. Not anymore 24. Not anymore 24, but 25. Why? Why I'm doing 25 when splitting the network? And here I'm giving the other part of the network, which is this, and I'm doing the same, 25 slash 25. I'm gonna let you think, but I kind of give it, right? I kind of give the answer. But you will see it's very interesting. I really love covering this. And it will be a perfect transition for network topology. So guys, when we say 25, we are I want to lock it. And this I want it to leave. So when we are mentioning 25 for the IP subnets, it's simply, again, it's all about bits, guys. All about that. Nothing less. How can I explain it the best way without too much like, I don't want to add too much information into this. I know that some of you already got it. So you have here 24, sorry. 24, when we do slash 24, it means that we are giving 8 bytes out of the 32. You know, we cover this here. We cover here. Here, you have no host. You have no host places. You have no room, sorry. You have no room for the host. So we are directly giving slash 32, like no room available. All the 4 bytes and the 32 bits are full. You have no place for anything. And why? Because it's the location of the device. It's the location of here my DC2, right? It's the location of my DC2. So here it means that it's full. Now here, when we say 24 bits, again, we leave 8 bits for the host. And what represent 8 bits? We just see this right now. It means Okay, 24 combination. It means 24 combination, okay? 24 combination. When we say slash 24 bits, how much we are giving to the host? Are we giving here, when I say host, guys, I mean this. What we are giving to the host. Are we giving 256? Are we giving 8? I don't know, like how much combination we are giving left to the host. So 25 minus 32 equals 7. 7 watts, 7 bits. How many 7 bits have for combination? Guys, we cover things here at the top. 7 bits have 128 combination. Why? Again, if you guys forget, you have here 7 bits, okay? 0 0 0 0 0 0 1 2 3 4 5 6 7, okay? And you want to find how much combination. So this, then this, etc., etc. You would have 128 combination. So that's why, and when you have 6-bit, for example, if I'm only giving 6 bits to the host, which is here, okay, here, I'm only giving, if I'm giving 6 bits to the host, I'm giving, remember, 64. It's only 64 combination. So here I'm only giving 64 combination, which means 64 laptops. Okay? 64 devices, which could be everything, IoT, laptop, phones, etc., etc. So, okay, guys, I hope you get the answer. So I know that some of you, I had it many times with, I'm not gonna say the name, but um, when they think about going from 24, which is 256 combination, okay, it's fine. 26 combination, 240, what I just put? Yeah, sorry. 24 bits left, it means 256 combination because it's 8 bits, which is 1 big byte. And 1 big byte, again, it's 256 combination. Most of the people, when they don't have a proper understanding of what is a byte, a bit, etc., etc., they think that going from there to there, it's like there is many things. Some people could say that it's 148. Why? Why some people could think that it's 248? Because of 8 bytes. So they think that they should only divide it 8, subtract by 8 bytes. Again, here 26 subtract by 8 bytes. But it doesn't add up, because when you will arrive to here, to 32, which means it's full, you will still have combination left. You will have, like, I'm just saying something randomly, like 220. So it means that you will have still 220, but how it's possible, since 32, if you see slash 32, it means that it's the location for the host, and there is no room for other host, which is normal. So guys, please look at this live every I would say every 2 weeks, every 2 weeks, every month. Go back here and yeah, just listen to what we said. Listen to what we said and what we covered here because it's a very important topics. And guys, in your whole career, you will heard about that. You will heard about where the network is, where the IP subnet is located. Now, what can I add more? Because I'm gonna go to um to place in my mind, and then I will forget the most important. Now, what is subnet mask? Okay, what is subnet mask? Subnet mask, it's actually uh, hold on guys, I will simply do this. I will simply unlock again. And I told you guys it will be the most interesting topic that we did. Um, but how you can okay, I just block it again. So yeah, subnet mask. Don't worry guys, I will keep my energy quite high until the end. So let me just fix my mic. Yep, sounds good. Okay, perfect. I'm just fixing my mic, guys. Okay, so what about now subnet mask? Okay, did I cover everything here on IP subnets? So as you can see here, if I could just cover like last time, the just like the last observation and notation concerning this, you have here one IP subnet that is located in sales, and you have another IP subnet that is part of the same big subnet, which is the one that we cover at the top. That is this one, I guess. Yeah, that is this one. And yeah, they both divided into two. So now what about subnet mask? So you are, let's say I'm just looking at the time. Mm, okay, so for the subnet mask, here it's our IP address, right? It's our IP subnet address. And again, on VMware, if you go to Virtual Editor, Network Editor, you will see that the IP subnet, it's the whole network, which is counterintuitive. Okay, I'm sorry, I don't know if I show you this or not, but you just go to Virtual Network Editor, and you will see that just at the bottom you will see IP subnet, and you will see like it's the place where your all network live. It's the network address. Okay, so here you have the network of the sales OU, which is 192.168.57.0, yeah, 0 slash 25. And here, so here we're going to talk about subnet mask. I'm going to add the subnet mask, and you will maybe understand it directly or not. 255, 255, 255, and lastly 100. Sorry guys. Oh, okay. Okay, so it's perfect, it's perfect. I reached the limit and it's at the perfect moment. Guys, what could be the subnet mask? Try to be this smart as you can. Try to be the smart try to be the smartest. Yeah, the smartest as you can. Just try to be smart, guys. Try to be very smart and figure it out. And figure it out that. Mm, okay. Actually, sorry. I can directly do this. I don't need all of them. So, for the one who who has a good thinking a good thinking method, it's actually it's actually going to be 100, and I'm gonna try to do this. Is going to be 100 again, 128. 128. Why? Because here we have consumed all the bytes. Okay, we have consumed all the 8 bits. So 255, like no room left. Here we have consumed everything, all the byte, so all the 8 bits, sorry, in little. So no more places, no more rooms. Here we have consumed everything. 1 byte, 8 bits, okay? And here we have consumed only the half. We have consumed only half of the network. So it means that we have um, another 7 bits left, okay? We have another 7 bits left. So it means that we have 128 28 combination left. So that's why here it's 128. It's think of subnets as the combination left. Okay? If for example my let's guys, okay, I just quit it, but imagine I don't have any IP subnets. Okay, imagine I don't have any IP subnets and my network is this. I'm gonna point another. I'm gonna create another IP address. So it's a new one, okay? 200, 500, 0, okay? And by the way, just for the new arrivals in case, 192 usually network address, local network address always start with 192.168. It's the standard. It always start with this. So yep, it always start with that. But here I'm just gonna make something like very different so you can see that it's a very different IP address. And my network address is this, okay? My network is this thing, okay? So it means that we are here 24 and I have 8 bits. Sorry, am I making a mistake? No. We have 8 bits left. So 255 256 combination, okay? 256 combination. What is the subnet mask of this? What is the subnet mask? What do you think? So here we have full. So it means that again, guys, we have 1 byte left, okay? 1 byte left here in this network. Here, oh, maybe I didn't say it, but it's very important. Guys, I forget to mention very important things. It's here. Think of it as the network portion, okay? This thing here is the network oh my god. You know what? It's fine. I'm not gonna it's fine for me. Um Here it's the network portion, okay? And here, guys, it's the actual host portion, okay? So here, let's go back to the subnet mask. To the subnet mask, here it's 255, okay? 255. Everything, like all the byte, is consumed by this portion here, by this small segment. Here, same. Everything, because we are in the network portion, so nothing left. Here again, 255. No room left. Here, same, 255. But here, we have a whole byte left. So, it means 0.0. Okay? It means that the subnet mask means that you could give 250, 56, 55, 250, sorry, 56 combination to this network. Okay, to this network. So yeah, guys, I hope that you could try, like, to see when you will create your lab environment, try to play with this and also notice what's going on. What is the subnet mask? What is this? What is that? Because most of the time when you go on YouTube and you see a tutorial for implementing your own VM, even the Udemy course, they don't explain this. Like the whole thing that I went with you, they don't explain this. They just directly say, yeah, put this, put 192, 168, 57.0, and then they just leave it there. But it's very important to have this concept in mind. So next time, try to play a little bit with it on your VMware, and if you have any question, anything, like, just tell me and I will help you out. Okay? So yeah, very very important topic, and don't hesitate to go back, on this live session to just have the right knowledge, just to put things in place, to put things in order. So, guys, like I said, it will be the perfect transition for network topology, because here we are covering the structure, subnet mask, subnet, IP subnet, and all those things. They are related to the structure, and we need to know what is the structure of this network. So basically, what is network topology? It describes how devices are arranged and connected in a network. Okay, this include two things that are very important. uh Please, sorry guys, I'm just going to wipe everything out. mm, Maybe there is a best way to do it. So guys, again, I'm just repeating what is a network topology. You will see this concept a lot. And network topology is, again, it describes how devices are arranged, where they are located, how they are connected to the network. And this include two things. Okay, this include two things. First, so this include two things, okay? This include, let's use my pen here. The first thing, oh my god, by default is go back to the big one. So network topology could be defined like this. The first one is the physical topology. Okay, the physical topology, which means how devices are physically linked with each, like between each other, how they are linked, how the cable, sorry, is it cables, is it wireless, what are we doing? And it's actually better if I, yeah, so yeah, I think it's fine. And then the second one is the logical topology. Okay, logical topology. What is the logical topology? It means how data flows between devices regardless of physical layouts. If you want to have, I will give you guys the best analogy for this. You need to think of a physical topology as a city map showing roads, and like buildings and all those type of things, like the structure. While logical topology is the traffic flow on those roads. So it's the vehicle that, so the vehicle is like the packets that go from there to there. So the vehicle that go, for example, in my case, I don't know, like from Paris to Lille to Lyon, etc., etc. So let's go back here, and I'm gonna give you the best. For me, it's the best analogy, to be honest. So look, road map. Maybe we should make city. It would be better. City map. Yes, perfect. So look, guys, here you have what you see here. It's it's a perfect picture. What you see here, it's the actual physical topology. I'm gonna mark it here. No, you can't. Let's put it there and there. So here you have, oh, sorry. Here you have the physical topology. Here, the house, the road. Okay, the road. Which is in reality the cable. Like, it's a device. For example, this one is a laptop. This one is a server here. Another server, a laptop, another laptop, a phone. Like, all of these things are part of the network, okay? And then what you have here, the road, is the actual cable, okay? So the cable, I can represent it this way. So this server is linked with this laptop. This server is linked to this phone, and this one to this laptop, this one to this, etc. And this server is same, is linked to this laptop, to this other server, for example. So, and how they travel? They travel through logical topology. It means that this actual core here, which is the data, he will go from the server and, for example, do this. Duck, and then go here. Okay? And now it's the work of the network engineer to make the best path possible. Maybe after maybe 1 year of him like changing the network and doing things better, Now maybe the data could go directly from here to here. But in reality, guys, what is happening? If you take, for example, your home network, what is happening in reality? Let's say you have here your, very simple, you are with your family and you have a house. Okay, you have a house and you have here sorry, you have yes, it's a house, but it's, for example, your laptop. Okay, it's your laptop. Let's say Johan. Okay, Johan's laptop. Then you have here another laptop, which is Luca. Then here Sofian. Okay, I'm just putting a random name, and um, I'm not pointing anyone here. And then you have here, let's say D for David. And what you have in the middle, let's say all of this section here, it's the router. Here it's the router. Well, sorry, router. So what is your city? How your city function? How the core, which is the data, work? It's actually very simple. It works that way. This one connected to here, this one connected to here, this laptop connected to here, and this other laptop. I didn't make any phone. Let's say here it's the phone of Tristan, okay? And Tristan's phone linked to the router, here to the router, and then the router communicate through internet, okay? Like they say, the cloud internet, which is in reality, guys, I covered this many times. It's only router and physical server. There's no cloud for. It's a very big misconception to have them calling them cloud. To call the internet cloud, it's a big mistake according to me. So you have here internet, which again is just router. Just many router, many servers. So how look, this is actually, guys, we are actually pointing network topology. So it means that whenever, for example, Sofian want to connect to a website like Canva, for example, myself here, so canva.com, he will go to the router and, sorry, blue. He will go to the router, so he will take a core here, he will use this core, go to the router, and the core going to leave the hometown through router, because router, they know about IP address, and connect to Canva, okay? And then it will go back, connect again to router, and go back to Sofian's laptop, okay? It's a very important notion and concept to know this, because, guys, if you want to troubleshoot anything, you need to know what is the network topology of your system. For example, you have a printer here. Many people have confusing about this. You have a printer here that is connected to the laptop of Luca. What is the network topology for this? First, here is Luca laptop. First, it connects to the printer and then to the router. Is it true what I'm saying? Or is Luca communicate to the router and the router communicate to the printer? And yes, guys, there is no connection between them. There is connection between him, Luca, the router, the printer, the router, the device. And many people, and if you want to troubleshoot anything, you need to be aware of this, okay? And there is a command line. I think I forget about. I I have how you say it in English? I forget the name when you lost memory of something. Um, yeah, I actually forget, but you could have routing um command line for what I'm trying to routing path data command line, and here you will see the command prompt for, yes, it's trace route. You can use trace route to say, for example, okay, let me know if I am for example here, sorry, for example here it's your printer, here it's your printer, and you want to see like how the network is actually working, and how it is, what is the network topology, simply as that, simply as this, and you will do trace route to your laptop. You will do trace route to your laptop and figure it out, um, and figure it out the how your packets travel. Okay, you will see how your packets travel. So he will told you, you first go to the router, and then you go to the printer. Okay, so it works that way. um so I think we did. So let me talk to you. Yeah, the next thing that I want to show you, it's just the different types of network topology. You have different types of network topology. The one that I just showed you guys, if I'm not mistaken, it's the store topology. Because for the home network, even company's network is also store topology, but it's a mix between store topology and bus topology, which is like, bus topology is cable. Like, you will see cable going, sorry, you will see cable going from everywhere, like everyone on your network. You will see cable a little bit like this, like my representation. So the laptop will be connected to the router through only cables, but usually these days it's only about store topology. It means that all devices are connected to a central hub. By the way, store topology and bus topology, it's almost the exact same. It's all devices are connected to a central hub or switch, but bus topology, if I'm not mistaken, is only through cables. Okay, but store topology is wireless. Okay, it's more wireless. Now the problem with in a big company, store topology is not a good thing, because it's a single cable for bus, or in the store a symbol. If the central device, let's do this way, if the central device, hub or switch, fails, the whole network is affected, and it's very bad. It's very, very bad for the company's network. So then you have ring topology, but we don't need to cover this. But the one that is important and is present in sorry in companies is mesh topology. And mesh topology, the physical layout is that each device is connected to every other device. And the example that I could give you for this is um, high redundancy corporate network. I can show you right now. Let me just wipe this. So I'm gonna show you what it's about. Okay, I know some people will be angry after me if I don't let the small details. Okay, so for example, a perfect mesh, a perfect example of mesh topology. I don't know if I put mesh if they will give me. I'm not sure. No, they won't. They won't give me. Yeah, let's use this one. For example, you have 3 servers, okay? And what you need is that in order to have a mesh topology, both need to be connected through a cable, but not like this. You will have like this. You will have this one that is connected, like let's say first, second, and third, and the first is connected to the third. The second is connected to both of them, and but it's like more than this. It's something like this. It's maybe we could look on the internet and you will have a proper way of looking at this. But it's like high redundancy in a way that all the servers are connecting between each other, and of course, guys, it costs a lot of money. It costs a lot of money for companies. Sorry. Mm, okay, you see. Yeah, because I forget very important things. But this one looks like a ring. It doesn't look like mesh. But you just need to know that, okay, full mesh topology. You see? So this one, sorry, I was pointing my hand. I'm really tired. I was pointing my hand. Um, this laptop is connected to every other laptop and disconnected, and same for this one. This laptop is connected with all other laptop. So it's what we called mesh topologies. Okay, guys, that's good. We need to go a little bit faster than this. So, guys, it's fine. Like really, we cover a lot. We really cover a lot for this topic. Then what can I say more than this? Let me check if we cover everything, because I didn't want to left to um yes, perfect, perfect. We will cover this. It will be the last. Normally it wouldn't be that long. Okay, guys. So the last thing that we will cover, is the OC model. You see how much we have, how much we have talking about networking, and it's not, we are not done yet. I know that OC model, it's really a problem for a lot of people. A lot of people, they are struggling with this. Okay, they are struggling with the OC model because it doesn't make sense. And you're right, guys, it doesn't make sense. Like, if you go here and you type OC model and you look at the definition, I'm sorry, but it doesn't make sense. For most of the beginner, it doesn't make sense. It's too abstract. And I remember when I started IT and I look at the OC model, I say, okay, I will just learn it by heart and that's it. And I don't know if you guys did this, but when I passed my Security Plus, my Contia Security Plus, I use this memo technique, which is, if I remember well, it's please don't do not throw sausage pizza away. And it's a way for me to remember what is the OC layer. So please, physical layer, do data link layer, and not, so sorry, and not yes on network, etc, etc. So then, guys, I will give you honestly the best analogy where you could understand what is the OC model. I actually already use it for my for when talking about network topology, I use it. I actually use it. I think this analogy, but we will do it again. So, guys, you just need the only thing that you need to remember for network topology. And let me do this. I don't know if I can do this. Nice. Just by copy and paste. Let's do this. Let's go back on what we take before, which is so we're gonna imagine a story, okay? We're gonna imagine a story. I hope he will let me draw because he was limiting me. I was limited before. So guys, let's start with this. The OC model explains how data flows through a network. But instead of listing layers, we're gonna use an analogy. Let's say we are sending a package from your house to a friend house, but to your friend, but in another city. So let's say here, let's say here it's Paris, okay? So I just want to do something. We're gonna do it a little bit like that. More like this, or maybe I can just and make it bigger. Okay, okay. Okay, great, great. And it's great because we will see here the actual OC model, but very in a very efficient way. So let's imagine you have Luca here. Okay, Luca, you are here, and you have Sofian here. Okay. Sorry. Let's say. So what we are doing here, the context of Luca's house and Sofian's house is that Luca wants to send a packet to his friend Sofian. Okay, he wants to send a packet, a package to. I say packet because I was thinking about networking, but that's great. He wants to send a package to, let's say, for example, if we're going here and we are talking and we are sorry, man, let's say nice guy. Okay, and another nice guy, but let's make a freaking guy. Okay, let's do this one. Where it is? Oh, so small. Okay, here it's Sofian, okay? Sofian's house. And here it's Lucas house. Let's do package. Perfect. So here, what do we want? Luca wants to send this package to his friend Sofian's, okay? So first, the physical layer. The physical layer represents the roads and vehicles. It's actually, as you know, the physical cable. When we are talking about the actual networking situation, it's the physical cable, the Wi-Fi signals, or fiber optics, it depends, and the roads and vehicles that transport are the one that going to transport your package. So in our case, one of the vehicle will take your package and go to the local post office. Okay, It go, for example, here it's your local post office. It's where here right now we are talking about data link. Okay, the number 2 is data link. So the first is just the road, the vehicle, the house, like, so it's the cable, the laptop, like all the physical things that is related to your network. Okay, so now the data link is actually and simply um, the truck delivering your package to the nearest distribution center, which is the local office. Okay, so here, so you have a guy that with a truck that will come take your package and will give it to the local post office. In reality, what is it? It ensures the package gets to the right local depot, which is the MAC address. Okay, the data link is just the MAC address. It means that MAC address layer 2, so switch, so for example you switch, in reality here, I don't know how to point it guys, but in reality here you're asking for your laptop to like, sorry, you're asking the switch to bring your packets to the local post office. So it's what the layer 2, so the switch which is a layer 2 will actually help you send this packet, which is just a packet, means it's only a data, it's only a 0 and a 1. We're only talking about one packet of data, 0 and 1. Okay, is going to help you with your packets, with your packaging to the local post office. So the switch going to use only MAC addresses. Right now we're only talking about MAC addresses, which every laptop, every switch, routers, every object in your network has MAC addresses. Okay, and we are using it for analyzing our local office, or sorry, our local city, our local hometown in our case. So because every house that you see here could be identified thanks to the switch. For example, the switch we will say is here, and thanks to the switch we could connect this, we could connect the whole network of the city. You see, the whole network of the city can help Luca find whatever people he wants. For example, if he doesn't want to send to Sofian, he wants to say, for example, to Tristan. So it means that we will only use the switch for this. It will only be the switch. We don't need anything else. So we will only use the switch. But OC model is not only about switch, okay? It's about other things. So it's just for the explanation, guys. So I'm gonna quick this up. Okay, so then network. So what do we want? Now we want another truck, a truck delivery, to go to the local post office and go to the other city. But what we need to go to this other city, look, it's empty, there is nothing, it's another city. How can we do it? We do it thanks to routers. Okay, thanks to routers. I don't know if we say routers or routers. I think we say routers. To these routers, okay? So the number 3 is this. It's the layer, okay? Sorry, it's the layer 3. So it's the network, and the network layer can talk with other cities, whereas switch can't, and router can. The layer 3 can talk with other cities. And what cities represent? It represents IP address. Okay, routers know about IP address. Whereas switch doesn't know about IP address, and we're actually covering what is the difference right now between a switch and a routers, which is switch operates at layer 2 at the OC model, and it connects devices within local network using MAC addresses. Okay, so same city, like same hometown, it can connect only to the local to your local home network. For example, the routers operates at layer 3 of the OC model, this one, and it connects different networks using IP address. So in our case, the city of Sofyan, and in the case of the lab, it was the thanks to the router, thanks to what we have here, we have Windows 2, okay? So we have DC2, so the Windows Server, Paris, that is connected to the other site in Lille, which is on another network, and it's thanks to the router, okay? So, okay, perfect. So now, sorry. So now we could go back on the actual analogy. So the purpose of it right now is to route the package between cities using IP address, right? So we are using, so thanks to the router, there's a truck delivery that will be here and go from there, because now he have the address, okay? Let's say the address of Sofyan is 192.200.400 and point 5, okay? But guys, there's a difference between a local IP address, which only your home router know, and your IP address, your network IP address on the internet, which is different. So I'm gonna give him a network internet IP address, which is something like this: 168 200 420 86. Okay, so yeah, it's fine even though it's very bad written. So now the router, and let's imagine that Lucas' net IP address on the internet is 168 same 86 200.400. Okay, so here your packets will actually, because now the truck delivery, the guy that going to deliver the package, know the address. Okay, he knows now the address, he knows the IP address. Okay, so he could go from there, pass to the router and say, okay, I know where it is and it's here. Okay, so now this whole schema this whole traveling how can I say it? Yeah, the way that the packet travel need a transport, okay? He need a transport. So what is the transport layer? The purpose of the transport layer is it ensures the package is delivered safely. What is it? What do you think is? It's TCP or UDP. So safely with TCP and quickly with UDP. And the analogy is that a courier service that guarantee delivery, he will tell you like, yeah, for sure the delivery will 100% will be there, and you can also track your device, you know, like all of this system that they implement nowadays with delivery package. And UDP, you just pay a cheaper price, and he will give it as soon as possible. Like, you maybe think of it as Amazon Prime, like you receive the next day, and it's exactly this. But there is no guarantee. Like there is no guarantee for sure that you will have it. Okay. So yeah, this one is very important. Now, what is the session layer? The session layer, the session layer is, and guys, just for the people that are new, you know, just look at what TCP and UDP is. But it's you will look at it. We already covered so much things today, and I'm so tired. So I will give you these parts to do. Okay. So session layer, you need to think of it like this. The purpose of this session, the session layer, it's like it ensures the package is delivered. No, sorry, it's for the. I'm confusing. No, sorry, guys. So this the session layer, it's like the phone call. Okay, it's like the phone call. It maintains the communication between sender and receiver. I was getting confused because I was talking again about the transport layer. But session layer, you need to understand it as it's a communication, sorry, not between sender and receiver. I'm making again a mistake. I'm really tired. It's a communication between the sender and the truck deliver. If we the truck delivery, I think is this. If we want to do a proper analogy, it's him, Luca, connected connected to, let me think about the session layer, how it is, how it's defined. Yes, sync send to port, maintaining connection, and it's responsible for controlling ports in session. Okay, yes, we could say sender and receiver. It's not like you have the truck. You need to imagine like this. You have the truck that going to deliver the package, and we have all three in connection together, like the sender, the receiver, and like we are observing what's going on, like where is the truck delivery, can it goes to this path, can it goes to this street, etc, etc. It's just maintaining proper communication between the sender, the receiver, and the truck delivery. So maybe the good analogy will be like some sort of a phone call, ensuring that the courier knows where and when to deliver. Okay, so like both of them are saying, yeah, you could go from there, then go to the left, then go to the right, and you could use this port. You see, it's really like the session port. We are communicating with ports, and then you could take left, and then you arrived. Okay, and then presentation is the presentation layer, which is this one. It's actually, it encrypts, presentation encrypts and formats the data for compatibility. So the analogy, Sofian is receiving his package, okay, and it's like the wrapping, we say wrapping, uh so it's the it's wrapping the package securely with clear labels. So we could say in the package that like, yeah, Sofian, and then we put a lot of I don't know, thing to hide what is the inside. We are hiding what is inside this package, you know. So yeah, so it's the presentation layer. It take care of encrypting. So now the 7 layer, which is application layer, it's like simply it's Sofian opening the door and use the content and use what is inside the package. Okay, so it's open it, He's opened the package and is happy to receive his package. So guys, it was an analogy. I hope that it was enough clear for you. I think it's better to explain it this way because it means that it's less, how can I say, it's less confusing. You see, less confusing. And you could, because I know that you guys already know this, like you already know this, right? So I don't need to cover like the actual networking um, word for this, because I know that you already covered this, but I just want to look at this quickly. And wipe it up. So maybe you could have like again a better understanding of this. So as you can see here, it's a human computer interaction layer where application can access the network services. Oh, sorry, it's the 7. I thought it was the first. I was so the 4, like we said, we talk about the 4 because let me put things right. We talk about the 4th, which is the transport layer, and in our case it was to ensure that the package is delivered safely. Okay, it's safely or quickly, and it's exactly what transport the protocol. Okay, it's the protocol. Do you want Amazon Prime like the next day delivered, or do you want to use I don't know. What is the best courier? I don't know how you call it, but delivery system, delivery companies. I think it's UPS, something like this. Okay, so do you want to use FedEx or UPS or Amazon Prime that going to deliver like the next day? Then here you have 5 session layer, maintain connection and is responsible for controlling ports and session. And in our case, it was this, yeah. Session, you need to see it like this. Like, sorry. This one I want. This one I want the big connection. It's this, guys. It's the connection between them. The connection between them. It's the connection between them, okay? So, yep. And then what they said here, 6 presentation layer. Ensure the data is in usable format and is where data encryption occurs. So you see, it's why I said about the packaging stuff. Like the package need to be very secure and it really hides, and it's going to be very hard for someone to unpack it. Okay, it's like putting I don't know how you call it in English, but let me check. Like a lock. Yeah, yeah, a lock into it. A chance, also they said, yeah, like a chance. Okay, great, great. I think it was enough clear for people. Then I think, guys, we cover so much things. Like I think we are good. Okay, guys, it was a long live session. I hope you guys enjoy it. I'm really tired. Um, I really enjoy it. I really enjoy it, and it was fun to go back on those different concepts. I hope that it helped you guys, and don't hesitate to watch again. Okay, and now we will proceed to the Q&A. But guys, please, maximum we need maximum like 15 to 20 minutes. I cannot do more than 15 to 20 minutes. Okay, guys. Okay, so let's go to the last and final part.